Starting out with a lot of crazy examples on the board right now. What we're going to be talking about is parallel line proportionality. If you remember a couple chapters back, we had two parallel lines cut by a transversal. What we are going to have now is three parallel lines cut by two transversals. The cool thing with parallel lines is when we cut them, no matter how we cut them, the sides will be proportionate because parallel lines stay the same. I just realized as I was looking at this, I didn't fully label this guy up here. So as we are creating our three parallel lines cut by the two transversals, we're cutting these side lengths into proportionate parts. And if you notice, if I were to continue on with these lines, I'd end up making triangles. So the same thing applies when we have parallel lines in triangles. So I've just got a bunch of examples up here, so we're just going to dive in and take a look. Again, when you have three or more parallel lines cut by transversals, these side lengths end up being proportionate. So let's just dive in. This first example, depending on how we set it up, I could go ahead and say 12 to x or 12 to 8. Either way, as long as I set them up in the same order. So I'll say 12 to 8 equals x over 10. We could go ahead and reduce our 12 to 8 and make that 3 halves equals x over 10. Cross multiply here. I'm going to get 30 equals 2x. So I divide by 2 and x equals 15. Done. Those side lengths are proportionate, set up the proportions and solve. With this second example, we got to be a little bit careful because I was given the full side, not both. The full side is 32, and then I was given the pieces here. We always want to make sure we're comparing the same corresponding pieces. So if I know these individual side lengths, I probably want these individual side lengths. But since they gave me the total, I could go ahead and find this missing piece. 32 minus 20, and this side length is going to be 12. So now I could go ahead and set up my ratios. So this one I'll do 20 to 12 equals x to 15. I'm going to go ahead and reduce this by 4, so I'm going to get 5/3 equals x over 15, and I'm going to cross multiply. So 3x equals 75. Divide that by 3, and x equals 25. Plain and simple. Okay, so this next one over here, my total side length is where my x variable is. So I'm not going to be able to do a lot of subtraction there. But this is the total, and I was given these two sides. So I could easily find the total over here is 14. So now what I'm going to do is I'm going to compare the total to this side, total to this side. So 4x plus 1 over 9 equals 14 over 6. As long as you're comparing corresponding parts, it doesn't matter the order and what parts you're comparing. So we'll go ahead and reduce smaller numbers, easier to deal with. Divide these by 2, I'm going to get 7 and 3, and I'm going to cross multiply. So 63 equals 12x plus 3 minus the 3, 60 equals 12x. Divide by 12, and x equals 5. Pretty simple, right? Okay. So like I said, if I were to continue these transversals and create these triangles, that's telling me if the third or this middle side is parallel, my sides are proportional. If you remember when we were talking about mid-segment, if this line bisects these angles, then it's twice the length at the bottom. But now we're just going to say this parallel line can be wherever it wants, but it does cut our triangle into proportional sides. So we can go ahead and set up those ratios. So here I have a side to the total, side to total. So that's going to be x over 12 equals 2 over 8. Reduce, so x over 12 equals 1 over 4. Cross multiply, 4x equals 12. Divide by 4, and I'm going to get x equals 3. Okay, same thing here, as long as we're comparing the same sides. So this is a total, so I'm going the total down here, which is 24, and then I'm going to set up those ratios. So I'm going to say 40 over x is 24 over 15. Okay, so that's 40 over x. Divide these by 3, so that's 8 and 3. Cross multiply, I'm going to get 120 equals 8x. So if I divide by 8, x equals 15. That doesn't seem right. 40 over x, 24 to 15. If I reduce, divide by 3, that's 8. Oh, that's 8 and 5, guys. That was weird. So sorry. But again, it's always a good idea to double check your work, right? That didn't make sense that they were going to be the same length, 15 to 15, so I obviously did something wrong. That was supposed to be a 5. So when I cross multiply here, I get 200 equals 8, 200x. Sorry, 200 equals 8x. Divide by that 8, and x equals 25. That's better, much better. Okay, and our last one's just a little bit more algebraic. Side and side, no total, so I'm going to take the 12 minus 10 to get this 2 here. So I'm going to have 10 over 2 equals 2x minus 1 over 3. The numbers are small enough, I'll just go ahead and solve here. All right, so that's going to be 30 equals 4x minus 2. So if I add 2, that's 32 equals 4x. Divide by 4, I'm going to get x equals 8. A lot of examples here. Take your time, go back, rewatch them. Slow me down if you need to. Go ahead and hit that 0.5 speed. I'm sure I sound great. If you got questions, let me know.